So today we're going to be talking about inverse trig functions. Okay, evaluating inverse trig functions. Okay. So, inverse trig functions are kind of like, well, they're the inverse of our trig functions, okay? So, for example, let's say that we've got y equals the sine of x, okay, is our kind of equation there, all right? And let's say we want to, find, find the x value if y is, I don't know, I'll say like negative 3/4 or something like that. Okay. Find the y value, or find x if y is equal to negative 3/4. So like sine of what, right? Sine of what is going to give us negative 3/4, right? Sine of what angle will give us negative 3/4. Now, that's not like a familiar thing to us, right? We have not seen that kind of thing, show up on our unit circle, right? We have no negative 3/4 ratio, right? If it was like y equals √2/2, then we might have a way to figure it out, right? We know angles that when you take the sine of them, you get √2/2, right? Or if it was like 1/2 or 1 or something like that, then we could figure out what those x values are. But for this case, we don't know what this one is, right? We can't kind of like guess and check it. We have to like come up with some way to solve this, okay? And so if I put that negative 3/4 in for y, and kind of, have my equation here, we could use our calculators to do this. For example, we could graph, the left-hand side, graph the right-hand side, find the point of intersection. But there actually is a command on our calculator to help us evaluate this problem. And the way we kind of want to do this with algebra, right, we want to get this x by itself. Right? Algebraically, if we're trying to solve something, we want to get the variable by itself. But right now we have this sine. All right? What we can't do to get rid of sine here, okay, we cannot divide both sides by sine. Okay, so, some people see, oh, sine is next to the x. That means it's sine times x, so I should divide both sides by sine. You can't just divide by sine. Sine of itself has no value. It's always got to be sine of something here. So sine, we're not dividing by sine here. This is sine of x. So to cancel out sine, we have these things called inverse trig functions. They undo sine. And here's what we do. We do sine inverse of the sine of x, like that. Okay? We take the sine inverse of the entire left-hand side there, and we'll also take the entire right-hand side, and we'll also take the sine inverse of the left-hand side. So sine inverse of both sides. Okay? I know that -1, right, to the -1 thing, that makes you think, oh, that's just 1 over sine. It's not the same thing. Okay, it's not the same thing in this case. That means sine inverse, which is just to cancel out the sine. It's not 1 over sine. Okay, so like sine inverse is not the same thing as cosecant. I know the -1 exponent, you're used to seeing 1 over sine, but it's not in this case. It just indicates sine inverse. Okay, an alternative way of saying this, instead of saying sine inverse like this, sometimes you'll see arc sine of negative 3/4, and those are synonymous. Okay. And in fact, if that's helpful to you, feel free to use arc sine. Like if you prefer that, if you feel like the sine inverse, sine to -1 is going to confuse you, you're going to think it's like cosecant or something, that's fine. Use arc sine. You can feel free to do that. Either they're synonymous though. You'll see them both ways, in fact. So you need to be able to be familiar with both ways. Either way, when we take sine inverse of sine, those are going to cancel out, and we're left with just x there. And then for right now, to evaluate that sine inverse of negative 3/4, well, we can go to our calculator. Okay. We want to be cognizant here. We want to be cognizant of what units we are in, or what, you know, and what units are we using here? Okay, so in this case, we're not told degrees or radians, so it's kind of like up to us to decide. I feel like let's just go with radians, since that kind of seems to be like the default, you know, angle measure that we're using. So I'm going to check to make sure my calculator is set to radian mode. Okay, and then I'll do second sine. So to get sine inverse, it's the second button, and then sine. You can see it gets like the little sine inverse command there. So there's sine inverse, and then we'll just type in -3/4. Okay, and so that's the radian measure right there, -0.848062079 radians. Okay, it's just some funky decimal there. Okay. So we'll say x is approximately that, -0.848 radians. Okay. If you're curious, because again, we're not so familiar with radians, let's just see what that would be in degrees here, just so we get a better idea. So it's about a -48.59 degree angle. Okay. To get a ratio of -3/4, it's about a -48.59 degree angle there. Okay. So that's how we can do that using our calculators. All right. Now, let's talk a little bit more about these inverse trig functions then. So we've got sine inverse of x, again, or arc sine of x. Okay. Alright, so we're going to look at these a little bit more in depth. The domain of these things, okay, the domain, that is the possible x values here. Okay, well, it's not -infinity to infinity. In fact, if you look, right, if I were to type in like second sine and I typed in like, you know, 100, it gives me an error. It's not in the domain. 100 is not in the domain. Okay. The domain for sine inverse is -1 to 1. Okay, the domain for sine inverse is from -1 to 1. The reason for that, well, remember inverse functions, right? Inverse functions are related, they're like reflections of each other over the line y equals x. So if we go back and think about sine of x, what is the range of the sine of x? What are the possible y values for the sine of x? What's the lowest possible y value we can get for sine? -1, right? And what's the highest possible y value? 1. So the range for sine is -1 to 1. Therefore, the domain for sine inverse will be -1 to 1. Okay? We can't plug in 2 because there's sine of no angle. There's no angle when you take the sine of it, you get 2. So that's why, you know, domain is just -1 to 1. Okay. The range here, though, is not exactly the same thing here as sine. So sine, right, its domain is -infinity to infinity. So you expect, oh, well, then the range will be -infinity to infinity. But it's not. We have to limit it to make it a function. Okay, we have to limit it to make it maintain a function. So the range for sine is -pi/2 to pi/2. All right, and then we'll just go through here, and we're only going to focus on sine, cosine, and tangent. We're not going to worry about, excuse me, doing secant or cosecant or anything like those, because, well, if you know sine, you can do the other ones too. Then, okay. So let's look at cosine inverse. We'll do a similar kind of thing here again, or also known as arc cosine. Okay. The domain for cosine inverse, okay, also is going to be -1 to 1, right? Because the range of cosine is -1 to 1, so the domain will be -1 to 1 for arc cosine, inverse cosine. And the range, okay, of cosine inverse, that's going to be from 0 to pi. From 0 to pi. Okay. And then tangent. Oh, question, Bailey? Yes. Okay. And then tangent inverse of x, or in other words, arctan. Whoops, misspelled it. Okay. Its domain is negative infinity to infinity. And its range, okay, is negative pi over 2 to pi over 2. Whoops, and that's supposed to be a y as well. I know, it feels like we just got familiar with sine, cosine, and tangent, and now we're having to go backwards, okay? Having to go backwards. Instead of plugging in an angle and, you know, getting an output of one of our ratios, you know, like the root 2 over 2, 1/2, root 3 over 2, stuff like that. Now we're plugging in one of those ratios. So we will take like the sine inverse of 1/2 and need to spit out then what's that radian measure that gives us that 1/2 there. Okay, so that's our goal, to be able to evaluate that. All right, so let's just kind of talk about a few of these here. All right, so for example, all right, let's you know, evaluate the following. Let's evaluate the following here. So let's do, for example, arcsine of 1/2. Okay. So arcsine of 1/2. When I go to evaluate something like this, I actually like to rewrite it. Okay. I mean, you can just look at it and say, okay, arcsine of 1/2. You know, what do we, you know, sine of what then basically is going to give us that 1/2. So I'm going to say this. I don't know what it equals. I'm going to say it equals some angle, right? Some angle theta. I'm just going to put that in. And then I'm going to say, all right, well, since arcsine of 1/2 is equal to theta, that means 1/2 is equal to the sine of theta. Okay? Just like arcsine cancels out sine, sine cancels out arcsine. They both cancel out each other. They're like inverses of one another. So if I kind of like take the sine of each side here, so to speak, okay, the sine and the arcsine cancel, I'm left with this. So while I was trying to evaluate arcsine of 1/2, I can now just try and think about this. And so now the question becomes, instead of what is the arcsine of 1/2, now I'm trying to figure out sine of what angle gives me 1/2. And so, what would that be? Sine of what? 60 degrees. Well, let's keep it in radians. So we'll say, oh, it's not 60 degrees, it'd be 30 degrees. So pi over 6. It'd be pi over 6. Okay, so theta is pi over 6. Okay. Well, let's just check our calculators to make sure that's right. So I'm going to go back to the radian measure here on my calculator. Okay. And let's see. Arcsine, so second sine. I'm going to put in 0.5, 1/2, right? Oof, that's a mess. Well, let's see if that's the same thing as pi over 6. And sure enough, it is. Okay, it's just a decimal, pi over 6. But there it is. Okay. So that's what we're doing here. So let's try. Or any questions on that? We can try another one here, just to see. Okay, get the hang of this more. Let's see here. Let's do arccosine Okay, excuse me, arc cosine of 0. Arc cosine of 0. Okay, again, I'm not so familiar with those inverse trig things, but I can say that's going to equal some angle theta, right? Again, arc cosine, you're plugging in a ratio, and your output is going to be an angle in radians, okay? Let's use radians. So again, we'll take the cosine of both sides here, cosine of this side, cosine of this side, and I end up with arc cosine and cosine cancel out, so I have 0 equals the cosine of theta. Okay. So again, the question is, cosine of what gives us 0? Cosine of what gives us 0? Cosine of what is going to give us 0? So this one's not one of our special right triangles, right? Our special right triangle doesn't have 0 on it. This is going to be one of those places on our unit circle. Okay. So we have 1, 0 here. We have 0, 1 here. Negative 1, 0 here. And 0, negative 1 here. Okay, remember cosine of the x-coordinates. So there's cosine, 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 cosine. Okay, and then there's sine for the y-coordinates. So for what angle does cosine of that angle give us 0? Pi over 2. Pi over 2. So theta is pi over 2. Okay, if I take cosine of pi over 2, I get 0. And sure enough, if I do second cosine of 0, okay, I get 1.570796327, which is pi divided by 2. Same thing here. Okay, so it works. Let's try another one. Let's do tangent. Actually, we got a question.
How do you know whether it's the 90-degree angle or the 290-degree one?
Okay, good. And I was going to get to that later here, but we'll cross that bridge since we're here. All right. So the question that Spencer asked was, in case you guys weren't able to follow maybe or something like that, we have cosine is 0 at both pi over 2 and at 3 pi over 2, right? Cosine is 0 at both pi over 2 and 3 pi over 2. So why did I choose to answer pi over 2 there instead of 3 pi over 2? Why did I include both maybe? Because both give us 0. The answer has to go back to the range. Cosine inverse's range is limited to be just 0 to pi. Okay? So in other words, we have to throw out that 3 pi over 2. Okay? Now, another good question might be, why is the range limited to 0 to pi? Why don't we just say 0 to 2 pi, or something like that? Well, it's because for cosine, all right, we include that first quadrant because that includes all the positive values of cosine, right? Cosine starts at 1 and then goes down to 0. That includes all the positive values of cosine that we could possibly have. And then we include quadrant 2 because that includes all the negative values of cosine. We start at 0 and go down to negative 1. If we should then include quadrant 3, we would we would also be including those same negative values of cosine. And if we were to include quadrant 4, we would be including the same positive values of cosine that we already have from quadrant 1 and quadrant 2. Okay? So the reason why we limit our range is to keep this thing to still be a function. If we didn't care whether this thing was a function or not, then the range would be just all the numbers. You wouldn't have to worry about, it'd be whatever. But since we care about it being a function, because when you think about the graph of cosine, right, it looks like this. Okay, and so on and so forth. Okay. If I take this thing and reflect it over the line y equals x, and there's line y equals x, and now I'm going to have a graph that looks like this. And this thing's not a function anymore, right? It's going to fail that vertical line test. So that's why we limit our range, in this case, be from 0 to pi. So that way we get the negative values of cosine. Actually, I think I messed that up. I think it should be this way. But either way, you get the positive values of cosine and then the negative values of cosine as well. I think that's right now. Yeah. So anyway, that's the point. Okay. So in other words, these ranges are going to be important to remember. Okay. Sine inverse and cosine inverse are both negative pi over 2 to pi over 2. Cosine inverse is just 0 to pi. So that way you have the correct angles here. So let's take a look at that kind of in practice. I think I've got one that I'd like us to do. Yes. So for example, let's do sine inverse of negative root 2 over 2. Okay, let's try another one here. Sine inverse, excuse me, of negative root 2 over 2. Okay, again, to evaluate that, I'm not sure what that is. I want to find the angle theta, such that when I take the sine of it, I'm going to get that. So I'm going to say, let's say it equals some angle theta. I don't know what it is. Let's say it equals angle theta. Okay. Again, inverse trig functions, your input is a ratio, 1/2, root 3 over 2, root 2 over 2, 1, 0, something like that. One of those normal things we get. Your input is one of those, and your output is the radian measure that gives you that. So again, I'm going to go ahead and take sine of both sides here. And so I end up with negative root 2 over 2 is equal to sine of theta. Okay? So now I want to know sine of what? Sine of what gives us negative root 2 over 2? Yeah, okay, so pi over 4, but it's not pi over 4, because pi over 4, it would give us positive root 2 over 2, right? So we could say, okay, so we could say, let's see here, so it could be 5 pi over 4 down here, right? Or what else? There's one other thing here. So 5 pi over 4 would, or what? 3 pi over 4 would be in here, that would be a positive root 2 over 2. Pi over 4 would be right here, that'd be a positive root 2 over 2, because again, all trig functions are positive here, sine's positive here. What about in this quadrant? What would this quadrant be? 7 pi over 4. Okay? But if you look here, 5 pi over 4 and 7 pi over 4, both of those negative. If we go to sine's range, 5 pi over 4 does not fit in that range, nor does 7 pi over 4. Right? 5 pi over 4, that's greater than pi over 2. Right? 5 pi over 4 is more than pi, so it's certainly more than pi over 2. And then 7 pi over 4, well, that's bigger still. So how do we come up with an answer here? What do we say? Do we say there's no answer? Well, no. Okay, no. Because here's the thing, right? Sine's range is from positive pi over 2, so that goes up to here. But sine's range is also to negative pi over 2. That goes down to here. Yes, we can call this 3 pi over 2, but it's also, isn't it negative pi over 2, because we're going the opposite direction here? And if you look here, that 7 pi over 4 is within that, but we can't call it 7 pi over 4. What should we call it? Negative pi over 4. Negative pi over 4. Okay, negative pi over 4. Okay, negative pi over 4. Okay, so the good news is for sine and tangent, okay, for sine and tangent, if you see that your ratio is negative, then just kind of make your initial angle negative, okay? So in other words, you know, if we think, you know, back to our original answer here, we just said pi over 4. Pi over 4 gives us root 2 over 2. Oh, it needs to be negative root 2 over 2. Let's just make it negative pi over 4. And that'll work for sine and tangent. For cosine, we're thinking in quadrants 1 and quadrant 2. Okay, so we have, you know, these values and these values here, which wouldn't be negative angles. They would just be, you know, 1 and 2 angles. Okay, so, but for sine and cosine, that works. All right, let's do another one here. We'll do one more and then we'll move on. Okay. Let's see, do I have another one? I think I do. Yeah. Okay, let's do one more and we'll just say, and maybe I'll have you guys try this one. So try this one. Let's do arc sine. Oh well, shoot, I've done all these arc sines. Sorry, let's make it arc cosine, just to change it up. Okay, arc cosine of, I don't know, I'll say negative root 3 over 2. Okay. So try that. Arc cosine of negative root 3 over 2. Arc cosine of negative root 3 over 2. See what you can come up with there. Okay. See what you come up with there. Okay. So I got down to this point. Okay, cosine of theta equals negative root 3 over 2. All right. So that means our theta would have to be what? Anyone want to volunteer here? What's our radian measure? Want to give it a try? Let's make it easier. Let's ignore the fact that it's negative root 3 over 2. Let's just say it's root 3 over 2. Cosine of what angle, so we're just in that first quadrant there, cosine of what angle would give us root 3 over 2? Well, we can go over here, right? Cosine is adjacent over hypotenuse. So here's, if we have root 3 over 2 and here's 2, we need this to be over this. So this needs to be the adjacent, and that needs to be the hypotenuse. So it's going to be pi over 6, right? But we need it to be negative root 3 over 2. And for cosine's range, that's from 0 to pi. So in other words, what's the pi over 6 angle in quadrant 2? 5 pi over 6. So the answer should be 5 pi over 6. Okay? So cosine, if it's negative, you just need to look for the second quadrant equivalent, angle. Sine and tangent, if they're negative, you need to look in the fourth quadrant, but instead of going, counterclockwise around to get to it, you just want to go clockwise to get to it. So it'd be like negative pi over 4, negative pi over 6, negative pi over 3, negative pi over 2, that kind of deal. Okay, that's the idea. All right. So, any questions on that before we move on? Maybe it's still a little bit uncomfortable, but I think it'll come with, again, some practice and stuff. So we'll continue on though here. Okay. And again, you're welcome to come in for a set and get some extra help and stuff too. All right, some other things we need to be able to do. So now we talked about inverse trig. Okay, there's this weird thing, and I'm not exactly sure why we teach it, but it's within the assessment limits, I guess, so I'm supposed to teach this to you. Sometimes, most of the time, I think the things I teach are like, okay, I can see how this is going to apply at least to like a future math class. This one I'm not so sure, but I still have to teach it. Okay, so we'll show it to you here. So what happens if we came across something like this? Okay? And some of you guys are thinking, well, why do we need to learn any of this stuff? Because I'm not going to use this in real life. Oh, there's a good chance. There's a good chance, right? You won't. But anyway, here we are. Okay? There's your motivational speech for the morning. So anyway, tangent of arc cosine is 2/3. How do we evaluate that, right? If this was tangent of the arc tangent, no problem. Tangent, arc tangent cancel, it would be 2/3. But tangent of arc cosine, how are we even supposed to, like, tackle this? Right? How are we even supposed to tackle this? Well, here's what we can do. Tangent of something. So this something here needs to be some angle, right? In fact, that makes sense because arc cosine, we're taking a ratio, and we're going to go backwards, and the output of this thing inside the tangent, the output of arc cosine should be some angle. So let's just call it some angle theta. Okay, and so now I've got tangent of theta, whatever that is. Okay, and I've got theta is really the arc cosine of 2/3. So I kind of like just did like a little bit of a, I used the variable theta because that's what arc cosine would be. It would be equal to some angle theta. So I'm just going to say, let's just say theta is arc cosine of 2/3, and now I just need to evaluate what tangent of theta is. But how can we do that? Like, what can we do? Well, again, we're not so comfortable with this arc cosine of 2/3 business, but if I take the cosine of both sides here, okay, the cosine and the arc cosine cancel out, and I'm left with 2/3. And again, we're like, 2/3, that's not even one of our ratios, Mr. Wickmeyer. How are we supposed to figure this out? Well, this is we can put this in a right triangle. So I'll put my theta in the right triangle there. Right? And from this information, the fact that cosine of theta has to be 2/3, I know that my adjacent leg here has to be 2, and my hypotenuse has to be 3. And remember, though, our ultimate goal here is to evaluate tangent of theta. Oh my gosh, there's theta. But to evaluate tangent, I need the opposite leg there. I have the adjacent leg, it's 2. I know the denominator is going to be 2. I need to find this this opposite leg. How can we find it? Pythagorean theorem, exactly right. 9 equals 4 plus b squared. So b equals the square root of 5. So what's the tangent of theta? Square root of 5 over 2. And so the tangent of the arc cosine of 2/3 is the square root of 5 over 2. Okay, just using our reference triangle there. Okay, and there it is. Tangent of the arc cosine of 2/3, 1.118033989. Square root of 5 over 2, 1.118033989. Okay, they're equivalent. Okay, so it works. It matches. Okay, I'm going to have you guys try one here. So try this one. Let's see. How about sine of the arc cosine of 1/2? Sine of the arc cosine of 1/2. What does that equal? So again, remember, arc cosine, that output is going to be some theta. And so we can really just evaluate what sine of theta is going to be and then go ahead and just figure out what is that theta. Or not what is the theta, but what's the triangle that we get there from that. Okay? And I'll let you kind of go from there. You can use your calculator to check your work, too. If you got it, you want to check to make sure you got it right. Check each one. So, cosine is 1/2. opposite over hypotenuse, not the adjacent side there. That's opposite of hypotenuse. Okay, so lots of good stuff. Very good. Should be, our final answer is square root of 3 over 2. Okay, so our cosine of 1/2 means that cosine of theta is 1/2, which gives us one of our special right triangles actually, right? And so then sine of that theta should be root 3 over 2, right? So actually our cosine of 1/2 we can evaluate. We know that theta, okay, we know that theta is going to be pi over 3, and then sine of pi over 3, root 3 over 2. So actually we know what that theta value is in this case, all right? Questions on any of that? I have one more thing real quick here, and then we'll be done. I think this is something that's been like reviewed for you guys. I feel like this next thing should be something that's definitely reviewed. You guys have seen this before, at least in geometry. Okay, and I'll just talk about that here real quick. So, you know, if we have, so we're solving for angles of a right triangle. Okay, that's one other kind of application of these inverse trig functions. Okay, so for example, and I'll just go ahead and, we'll just do one of these here. So let's say I've got a right triangle here, and I want to find the measure of angle theta. And this is all the information that I have. If I had this other angle, right, I could do 180 minus 90 minus this angle and get that theta. But all I have is that one angle theta and the 90-degree angle there, so I can't do that. But I do have the opposite side to angle theta, and I have the hypotenuse of the right triangle. So what trig ratio could we use to relate those three pieces of information? Sine. So we could say the sine of theta is equal to 3 over 5. But then the question is, what the heck is theta? How are we supposed to find theta? Well, here we're going to use sine inverse. So do sine inverse of both sides, or arc sine of both sides, however you like to write it. Okay? And so we end up with just theta is the sine inverse of 3/5. What's that? Well, type it into your calculator. Sine inverse of 3/5. I get 0.644, I guess I'll say rounded up. So theta is approximately 0.644. Of course, that's in what measure? Radians. So if I change my calculator to degrees, and I type that same ratio in, I can now say, okay, that's about 36.870, it looks like. Okay, which again, in the terms of a triangle, it may make more sense for us to put it in degrees. Hopefully your directions, I think your directions should be specific. If they're not specific, then you can use either measure you want. Anyway, that's how we solve for missing angle. And now once you have that angle, we can find, the other angle by subtracting from 180 and, get that. Okay. So that's it. Just inverse trig to find those missing angles. Okay, so let me give you one here to try, and then we'll be done. So let's see here. Again, find the measure of angle theta and these triangles are not drawn to scale, so there you go. Okay, so your final answer here should be 60.945 degrees, or about 1.064 radians, just using tangent inverse there to get to that. Tangent inverse of 9/5. Okay. Questions on any of that? So your assignment is up there on the board. Okay, 5 to 15, 27 to 31, 55 to 59, 71 to 73. Those are all odds. Please, the odds. And then 106, you get one even from there. All right. So there's that. And please do get started on this, especially those tricky,